Okay, so I have started the recording. So I was talking about inheritance. This is what we did last time. And abstract class and interface is what we are going to do today. And abstract class and interface is something which is very, very, I should say, root of the heart of inheritance. Inheritance is just a concept, but we have multiple ways in Java to achieve inheritance. Okay. So far what we have seen is we can inherit a class to its child classes, right? So there is a parent class and there's a child class, because child class extends the parent class, right? So this is a relationship, and that's how we are able to achieve inheritance here. But in both of these cases, one thing to note is that they both are concrete classes. Okay. Now, what do I mean? What do I mean by concrete classes? So, concrete classes are the classes which has proper definitions of behaviors and the attributes. Okay, they have everything is defined there. You won't find anything which is not defined in concrete class. So, what is the opposite of concrete class? The opposite of concrete class is abstract class. That means we have a class which has half of the information, right? It doesn't have full information about the class, but it does have half the information, uh, like what that particular behavior can do, what that particular behavior is, what how it's going to do that is not defined there. So what I mean by this is, maybe if I see this example, this is an inheritance example. So this is might not be that good example for my purpose of what I wish to explain. Let me open some other one. Maybe this. So whatever classes which you have here, we have class sample3, sample2, sample1. All of these classes have methods. So this is the what part, right? And this is the how part. This is the how part. So what and how both are defined, and that makes it an concrete definition, something solid, right? Concrete means something solid. So that definition is here. So this class is a concrete class. This class also is a concrete class. They all are concrete classes because there's nothing which is not known about this class. Everything is known because how the definition is there, how the definitions has been implemented. All that information is here. Okay. Now there's another concept called as abstract class, right? The opposite of concrete class is abstract class. Means we can create a class or entity which doesn't have all the information. It could have some information, but not all, right? Not full. We'll talk about why on earth we are going to need something which doesn't have full information, right? That we'll talk about it later. But right now I'm focusing on the concept. So concept, opposite of concrete class. So this is a concrete class. Opposite of concrete class is an abstract class, right? So when I said it doesn't have all the information, I meant this. So here there's a class A, but it is marked as abstract, right? And since it is marked as abstract, I have the privilege to mention the what, but not the how. Means I can mention what it should have. So only declaration. It should have only declaration, not the complete definition. So about any method, this actually is a signature of the method, or also called as declaration, and this becomes its definition. Okay. So in the case of concrete class, which was this, I had everything. I had the method as well as the declaration as well as the definition, both of them, isn't it? But in the case of abstract class, I don't have it. I don't have the luxury to, or I have a privilege or luxury to not mention the definition. So here I've just simply written abstract void test1. That means I'm saying there's a class which is a type of abstract class, and that abstract class has a method test1, but it doesn't have any definition because I don't want to define the definition of it. Again, I will talk about why on earth we need something like this, but that we'll talk about later. I try to give an example on why you're going to need an abstract class. Okay. So here it's pretty simple: abstract void test1, abstract void test2. Right. So I have two such methods which has no definitions. But can I have a method which does have a definition? Yes. So in the abstract class, you have two options. Either you can choose to put a definition of a method, or you choose not to provide a definition. So an abstract class allows both, right? As I said, you have this luxury and privilege to mention what you wish to define and what you don't wish to define. In both the cases, it will work. What won't work is then you try to do something like this and you don't write this here. Then it won't work, because if you want to have an abstract behavior, it has to have inside an abstract class, right? So if you want to do something like this, that means you don't want to define, you don't like the idea of defining something in the beginning. You're thinking, let me just declare it, and then maybe later I'll try to define it, because right now I'm not sure who is going to work on it. So I'll say, I'll just declare it, I'll not define it, right? But this is not the full work. This is half work. That means you want to do something, you want to define or declare, you want to declare something, and then later you want to work on it. Something like you want to do something tomorrow, so you can't do it, you can't do tomorrow's work today. So what you do, you create a list, right? You create a list and then you write the items that becomes your to-do list. I want to do this, I want to do that, I want to do XYZ, right? Something similar to that. So here, once when I created abstract class A, I had something in my mind that I have to have a behavior called as test1, and I have to have a behavior called as test2, but I can't do it today. So I will do it tomorrow, right? And maybe tomorrow, maybe I won't do it. Maybe someone else will do it. Okay, for example, you are a boss and you want some tasks to be done, but you won't do it because you are boss. So someone else will do it on your behalf, right? So what you do, but you do know that these items has to happen. These item needs to be worked upon. So you will create a list, right? You create a list, and that list you're going to hand it over to your workers, and then your workers will then know what exact items to work upon. Something like this is happening here. Okay. So abstract class A, when you say abstract class A, this is something which your boss created. Things to be done. Okay. And then your worker came and you handed this list to your worker, and your worker will now know what exactly needs to be worked upon. And based on that, he will override these methods. So how it happens? It's something very similar to how we learned inheritance. So it has to have a keyword called as extends. So B, class B extends A. Class B is created by your worker, and class A is created by your boss. Okay, and your boss basically has told you to work upon these two test1 and test2 methods. And now, since you are extending the A class, now it's your duty to override this, to implement these methods. Okay, it's your obligation to do it. If you don't do it, then you will get an error. Okay, so that's how the boss is enforcing this work here. Okay, this enforcement was not possible here in the case of normal inheritance when we saw this example, right? For example, this one. Now you have a test1 whose definition is already defined. Definition, declaration, everything is there. So in the sample2, sample1 extending sample1, sample2 extending sample1, and in sample2 you have no specific obligation to override the test because the definitions are already present. However, if you choose, then you can do that. If you choose, then you can override this. If you choose, but there's no obligation. Okay, so now here this has been overridden because I have done this. I am in sample2, something like this. So this was plain inheritance because you are trying to establish a relationship between two concrete classes. Okay, but how will you, what are the ways available to you in Java to enforce this to do, enforce this overriding feature? That you can do using abstract class. And this is what I'm trying to explain here. If you don't do this, then you will get an error. That means you are forced to implement test one. Okay, so this is a big difference between normal concrete class inheritance and abstract class inheritance. In the case of abstract class inheritance, if you are extending an abstract class, then you are forced by designer of Java by Java itself, you are forced to implement class A. What are the things you are forced to implement? All the methods which are abstract, which are not defined. Those all such methods you need to kind of implement. So now that's what is happening. Void test one, this has been overridden, and void test two, this also has been overridden. Okay. Now class B has implemented class A successfully. And now when you want to create an object of class B, so you can just do it as it is. The way we do it, we first create the object of B, new B, and then B.test1, B.test2. Any doubts so far? Okay, it's pretty straightforward. Let me go to a next example. Now, test one was quite, I should say, nonsensical because it was class A, class B. When you actually work, basically, this is when you actually work. Yeah, so the question is it necessary to have abstract method in abstract class? Is it necessary to have abstract method in abstract class? Okay. So the question is it necessary to have abstract method in abstract class? So let's try it. Okay, so the answer is yes. So if you don't mark a class as abstract, you cannot keep abstract methods here. Make type A is abstract. Okay, because by design, the thing is, if you have an abstract class, okay, the idea is you cannot create an instance of it. If you try to create an instance of an abstract class, it doesn't make sense because the class is incomplete. So you cannot afford to have a class which is incomplete. Can you? You can't, because that is of no use. You can choose to have a class which is empty, which is just fine because that is an empty, it doesn't have anything, right? But you cannot choose to have a class which is half complete, half done. For example, if Java allows you to create an object of class A and you try to invoke the test one, which is abstract, what it will do? So Java will be confused. Okay, we have a declaration, we don't have a definition, which means I don't know what to do with this method call, right? So that's the reason. If you are having an abstract class, then you can keep an abstract method. What about non-abstract method in abstract class? Yeah, so that you can do. That will be demonstrated in my next example. Okay, so as I said, you can create an abstract class and you can have only declaration, but you can also have such behaviors which do have a definition. So abstract class accommodates both. I'll talk about it in the next example. Abstract class accommodates both types of method. So it can have an abstract method and it can also have a concrete method. So you can also create a method like this here. I am implemented. So this is allowed in abstract class case. So abstract class can have abstract methods and concrete methods both. This is allowed in the case of abstract class. But still, you cannot create an object of it. So if you're marking something an abstract, then you cannot create an object of it because still test one and test two is not defined. Okay. Now let me move to the next one, test 2. So here, something similar. In this case, it make more sense. So here, abstract class, animal, move, and sound. Two methods. Imagine maybe, okay, let me take an example later. So, just plainly, these are two methods, move and sound. And here you have an animal called as dog, because dog is a type of animal, right? And now dog can be implemented like this. So dog move, sound, dog, bow wow. Here the cat, we have an animal because it also extends. Cat moves, meow meow, right? And then you can create object of it. So what do you guys understand by this example? Let me maybe try to explain. Okay, guys, give me a minute. Yeah, sorry. Right. So what do you really understand by this example? So see, imagine God wanted to create animals, right? And God had few workers. Now God knew what is to be created and how it would behave. So God said, I want to create animal, and it should have two behaviors, move and sound, right? So God has created this class. Or in some sense, you can say this is a template which a God created. I hope everyone knows what template is. Template is nothing but a, you can say, blueprint or a basic structure. Something like you want to have a building created. First of all, building won't get created by itself. First of all, we need to create a blueprint. Who create the blueprint? Architect, right? So architect will decide how is the layout, what are the things we should be having in this house, and based on that, a complete full-fledged building can be created by the engineers and workers. This is something similar to that. This is a template which the architect created, and these are the concrete classes. So concrete class 1, this is concrete class 2. Imagine this is a class. Okay, let's say architect created a house, and house ID is, let's say, the first floor house. Okay, so the first floor, this will be the first floor. Then this might be the second floor, because in second floor it could have different features, right? It could have different kind of implementations. So this is your second floor. So the idea which I'm trying to establish here is that the use of abstract class in Java is used for templating. Before you even go ahead and start creating your classes, first step is always to create abstract class. So no matter which project you are working on, so the first step which you do is always create the abstract class. No Java programmer, no Java developer immediately start creating classes. First step which any Java developer will do is to start making abstract classes. So we need to identify what are the areas, what are the things which needs to be created, and those things are usually nouns, and based on those nouns or things, you first create abstract class and you assign behaviors to it. Okay, and then later, once all your abstract classes are ready, or an abstract class or interfaces, I'm going to talk about interfaces as well, both solves the same purpose but in a slightly different way. So abstract class you first create before you do anything else in your Java program. However, we automation testers, we don't really are not very good believer in creating abstract class. We don't create it, which is a wrong thing to do. Even any good framework, automation framework which you create, the first thing is to know what your framework is capable of doing, right? So the what part has to be identified first, and then the how part. The problem which we cause ourselves later, the source of all the problem is that we immediately try to implement how. Rather, we should be first be focusing on what and then how. So this is your first step. Step 1 is what. Step 2 is how. Okay. What is the first step, and this is also called as templating, or this is achieved in Java by abstract class and interface. I hope this is actually a common confusion which people have on, and they don't know when exactly you need to create abstract class and when you need to create direct concrete class, right? So this is a basic understanding on why you need abstract class, because you cannot just immediately start creating the concrete classes. You have to first identify what exactly you need, and based on that need, based on that what part, later you're going to create the how part. Now there can be two things. Maybe I am the only developer who is working on it, so we'll say I know exactly how to implement it, so what is the need of this? So the idea here is simple. You might be working alone today, but maybe later you might not be here, or maybe later someone else gets added to your team. So how will you tell them what needs to be created and how it is to be implemented, right? So this what part is kind of disciplining the next person who joins your team. For example, dog is being created, so someone gave this list, this is to be created, and next person who comes, he creates the dog class, and then he goes away, and then there is a next person who came and he wanted to implement the cat class. Now imagine he don't have any guideline, right? He doesn't have any guideline that how a cat is to be implemented. So what he might do, he might start making mistakes here. He might implement unwanted methods which is not supposed to happen, because the architect has defined how an animal should look like. So animals should have these properties, move, these two behaviors, move and sound. And if the second person is not aware, then he will not implement them. He might start implementing something stupid, something different kind of methods, which will completely spoil the application, right? So abstract class in a way is also a good way to enforce on all the other workers who are going to work on that specific piece. By implementing this, when I say this is the abstract class for anyone, everyone has to implement this. Everyone has to extend this and implement this. And once you do that, then there will be a sense of uniformity in all your animals. So now if I have this animal implemented, extended to all of my child classes, I have a sense of uniformity, that all my animals will have these two methods for sure. If I don't extend this, then I can choose not to implement this, which will be a wrong thing, because cat does make a sound, right? But now I haven't extended this. Now there is no uniformity between cat and a dog, which is a wrong thing. And this brings a lot of bugs and issues and havocs to the application. And your automation framework is not separate. It's also a piece of software, and it also needs to be standardized in a lot of things. All right. So this gives you a sense of uniformity. This templating thing gives you a sense of uniformity. I mean, you can say, I don't need abstract class. I can just write it in a piece of paper. Okay, you can do it in a piece of paper, but that way also you cannot enforce it. What I'm stressing, the point I'm trying to make here, I'm emphasizing, is that you need to enforce the template. And this is how I enforce the template, that you have to implement or extend this. So see, if I don't have this sound implemented, so it will give me an error. So that means I have to implement this. Otherwise it will keep on showing me error. So that way the subsequent developers can be put in check, right? They cannot make mistakes, because the compiler will not let them make mistakes. What was it? Meow meow. Okay. All right. So this is the gist of why we need to use abstract. I will try to give another example maybe later. But this is the complete gist of why you have to make use of abstract class or interface. So abstract class, interface are entirely one and the same thing. There's slight difference in how they're implemented. Otherwise, conceptually, there is no difference. Both has the same purpose. Okay. Now I'll come to interfaces later. Let me just walk you through this abstract class values. So here, the same thing here. If you notice, I have abstract class. Then I have another class. This is a concrete class. The concrete class can have two things. It has to implement this. So it has implemented this, right? And it has overridden, but it can also have something of its own, right? So here, in this case, this is a constructor. Here I'm just setting the value, but if I choose to have another method here, I can. So I can choose to have a method here, and I can choose to have a concrete method here. Doesn't matter. In abstract class and the child class of the abstract class, in both ways, I can write my own methods, my own implementation. No one will stop you from doing that. Okay. Yeah, this is the example which I've already demonstrated. So here you see test one is the only one which was overridden or implemented, not the test two. So it is giving me an error. It is saying I won't allow you. You have to implement this. I will not allow you. Okay, so this is again that example. Now let me come back, or rather start explaining you about interfaces. Okay, so interface, I have few more examples to demonstrate because it has few more functionalities. And as I said previously, there is absolutely no difference between an interface and abstract class in terms of concept. Conceptually, they are one and the same thing. Only difference is they're two faces of the same coin. You can understand it in this way. Okay, so the both has the same purpose, that is templating. That is what and how. Interfaces and abstract class both solves the same problem. Templating, uniformity. Okay, or templating, if you don't understand templating, you can understand blueprint. Okay, so first you need to define the blueprint of something, and then you go and implement it, and that way you can bring uniformity. So if you're doing blueprinting, it could lead to uniformity. Okay, I hope you are clear with this, because if you're not understanding this, then you can use an interface in abstract class, but you will be blind on how and when and for what purpose you're going to use that. So this is something which is very important to understand, that why you have to make use of interface in abstract class, because idea is very simple. When you try to do something at home, you do not just start doing it. I mean, you sometimes do that as well, but there's always a good way to do is to first plan it and then do it. So your interface and abstract class are the means of planning, right? You first plan and then you do it. So this is your planning interface as well as your abstract class. You do planning first and then you actually implement them, right? So this is your plan, this is your implement, nothing else. It looks huge basically in what are interfaces, because I have heard people worrying about interface and abstract class, but really it's quite simple. And if you understand the gist of it, why you need this, then it's pretty simple to understand. Anyway, I'll move forward. So here, similar to abstract class, you can define an method which is an abstract method. That means it doesn't have any body. It doesn't have any body. And if you try to put a body here, what will happen? So if I say void x y z, I'm getting an error. And this is a basic difference between an abstract class and interface. This is the only difference, basically, nothing else. I mean, of course, there are a lot of differences. When there is a huge 12-point table which you can memorize to explain an interview, but that doesn't matter here because we are talking from more practical perspective. Okay, so there is the only difference is that when you go and create interface, you cannot have a concrete method inside the interface. A few of you might find me wrong, and I'll talk about it later as well. But originally in interface, if you have an interface, you don't afford to keep any concrete method. All the method which are present inside the interface has to be a abstract method. You cannot have a concrete method present here. Okay. In the case of abstract class, you can. So here you notice I created an method which is not abstract, and this is allowed. But in the case of interface, this is not allowed. This is entirely not allowed. You cannot do this. However, after Java 8, so we are all are supposed to be using any version of Java which is above Java 8, which is Java 8 and above, I should say. There you have a mechanism. So Java 8 gave a mechanism to have a concrete method inside a interface, but that has to be marked with a keyword called as default. So now if I'm able to do that, now there is absolutely very little difference left between interface and abstract class, because this is the primary difference between having to use interface and having to use abstract class. Otherwise, there's no solid differences. Only main difference between interface and abstract class was interface, you cannot put any concrete method, but in abstract class, you have an option to put in concrete method. But once this feature came, now there is no difference. See, here I can have a concrete method. So here I can have an abstract method and I can have a concrete method. This is my abstract method, because I do not have a body here. This is my concrete method. This is my concrete method. I can have a definition here, right? And if I go and compare this with the abstract class, same thing here as well. Here I have this abstract method and I have this concrete method, right? So this brings interfaces and abstract classes at par to each other. So you can choose interface or you can choose abstract class. It's up to you which you want to keep, because both doesn't have any differentiation between as far as what you can keep inside it. You can keep method, abstract method, as well as you can keep concrete method. Having said that, there is still a lot of differences, lot of subtle differences, and in some sense, big differences as well, right? I'm not going to talk about all of them, but few. So in the abstract class, you cannot create an object of it, right? That we have made sure of, because if you try to create an object of this class and you don't have a definition, so the Java compiler will be confused on what to do when this test1 is called. So it will right away say, no, I will not allow you to create an object of abstract class, as simple as that. Okay. And same thing happens with your interface, right? Interface anyway, by design, it's not supposed to have anything, and this was added later. So by design, interface is not supposed to be having any, you cannot create an object of interface. I mean, it's not allowed basically. Now, next thing is in interface. So abstract class usually has, all the typical features of a class. I mean, it can have a constructor, it can have variables, a lot of different things. All the things which is available with the class, abstract class also has it. Only thing is you cannot create an object of it. Apart from that, you can have everything, or it can behave in the way a normal class operates. Methods, constructors, parameterized constructors, overloaded methods, variables, all those things. But that is not the case with interface. Okay, interface is slightly different in that behavior. It doesn't have a constructor. You cannot have a variable which is a non-static one. Okay, so you cannot have basically a variable declared here. For example, if you say int like this, you will get an error. It will say it has not been initialized. Okay, so you can say 9. But once you do that, it actually becomes a static and final. So actually you can only keep, it looks like it is not, you can modify its value, but you cannot. So by default, compiler adds public. First of all, you cannot make it private. It has to be public, static, and final. Okay, you don't see these 3 things here, but compiler automatically adds it. Second thing is abstract class has object as its parent. or as we discussed this in the last class, object class is a parent of all, but not in the case of interface. Okay, so this is what I was saying when I said there are quite similarity between interface and abstract class conceptually. So by concept, both has the same purpose. Their reason for existence in Java programming language is same. That means to plan. So you can use either interfaces or you can use abstract class for planning purposes. Now there can be a question on where, in what circumstances you can use interface and in what circumstances you can use abstract class. Now that really depends on what is the problem statement. Okay. Now that depends on how you want to categorize your subclasses or how you want to implement your subclasses. If you have a desire to implement your subclasses in a multiple inheritance format, that means a single child class, if you want it to have multiple parents, then you cannot use abstract class because abstract class will not allow that. But interfaces, you can do that. Okay, so it really is dependent on how you want to do it. In my opinion, abstract class, having to use abstract class is safer than interface because, as I said, mostly you won't be doing something like this. Okay, I'm not saying this is not usually people do. I'm saying you are an automation tester. Your job is going to be in automation testing. So mostly probably this will be kind of a bad design for you if you go and create a framework in such a manner. Having multiple interfaces to be implemented inside a single class. That's all I'm saying. I'm not really saying this is how it should be done across. No, it's really up to you to decide in what cases you can use abstract class, in what cases you can use interfaces. And if you have a choice, you can use abstract class because abstract class has a lot of different good features which interface might not have, because you can, in abstract class, you can have variables, you can create constructors, you can create a lot of different things. Okay, but interfaces that is a little bit more restricted. So if you really want to, if you're confused what to use, then you should be using abstract class, like a thumb rule, which I was talking in the previous cases also. Sometimes you have to go by the thumb rules, which is if you're confused, then go with the abstract class. The way I talked about when you're confused whether to use static or not. So thumb rule is if you're confused whether to use static or not, so don't use it. That is a thumb rule. Here the same case, if you're confused whether to use interface or abstract class, use abstract class rather. Okay. Now let me go to next example. I hope you understood the interfaces concept. Okay. If not, then you have to let me know, or maybe if you have doubts, you can ask in the chat. Let me remove this. This was plain example. Now test 2, yeah, this is just a syntax. So declare constant fields, because I said you can only have constant fields. Declare methods and that abstract and by default. So I've tried to explain all three. The Java compiler adds public and abstract keywords before the interface. So this is what I talked about. If you have a abstract class, it will add these values there so that you can't kind of change it later. Another example, drawable. So when you are developing an application which is supposed to be drawing something, so you will not you should not be immediately start implementing the rectangle and circle. You will first implement, because you need to plan it first. Your plan is to draw, right? So that you have to put inside a drawable interface, and then subsequent classes you can implement drawable, and everywhere you will have a draw method. So that way it becomes quite simple and it becomes quite uniform, that everyone would know that anytime I want to draw something, I'm going to create an object and I would declare it as drawable. If you see here, this we discussed in the previous class, and I have an assignment also posted there, that if you have a class which has a parent, then you can declare that variable as its parent type, right? So I want to create a circle, but I am declaring my variable as D. Okay, and I'm just doing d.draw, and that is it. If I want to create a rectangle, Same thing I will do. I will say D is equal to new rectangle. I will say D dot draw. So you see, I am kind of reusing the same variable. If I would have done it like this, then I cannot do this because the D here is a type of a circle, right? This is an additional advantage, and this is the only reason why we use this to achieve runtime polymorphism. Okay, so if you notice, drawable D dot draw. So D is a type of drawable, and when I'm doing draw, it is invoking the circle method which is present here. And when I'm saying D is equal to new rectangle, so D dot draw, which is actually this, is invoking the rectangle draw. Okay, so at runtime, it is deciding which draw to call based on what I'm assigning to this variable. Okay, you will see its implementation in your Selenium test cases. When you create Selenium test cases, there are a lot of even in Java, when you use Java classes, they have very good use of interfaces. Everything is designed using interfaces and abstract class. If you go and see the collection library, it is very good example of how an interface is being implemented and what are the advantages which you're going to see there. Right, so we'll see those examples, but just to give you an insight, a glimpse of how it would look, it is this. This can be called as runtime polymorphism, because at runtime, draw is invoking based on what it is. Based on what, maybe if I can just show you with some examples. So let's say I can say public void get shape. Just for an example, I'm saying this. If you understand, which is a good thing. If not, then don't worry. We're going to do all of this again, perhaps. If the type is equals circle, then return D is equal to circle, else return D is equal to new rectangle. Okay, so what I can do is I can just remove all of this code from here. See, here also you have this written here, real scenario object provided by the get drawable. So I should be creating something like this, get drawable. And all I would do is, instead of doing this, I will simply say, I call this method get drawable, and this actually should return the D, which is drawable. So I should say get drawable. I would say circle, and here I would say drawable. That's it. Okay, so now if I say circle, it will return me the circle, and I can just simply say D dot draw. So I don't have to decide here which draw I need to invoke. I can invoke this draw, and I can invoke this draw based on the string, simple string which I am passing here. If I'm passing rectangle, it will send me the rectangle one. This is runtime polymorphism example. This exactly is what happens when you do WebDriver equal to new Chrome driver. This is exactly what happens. All right, if you understood this, good. If you're not, then try it hard to understand, because this is the gist of why we use interface and abstract classes. This is the reason we do this. This gives us loose coupling. This is loose coupling. This is called as loose coupling, and we achieve loose coupling by doing this runtime polymorphism. Okay, by making use of this interface. So see, multiple concepts in play here: polymorphism, abstraction, okay, these are all the concepts which work together. They are not separate topics which you can understand separately. You have to picturize them in play, how they are interacting with each other. So here we have encapsulation, because yeah, of course we are using in class, and class is a symbol of encapsulation, keeping multiple entities, behaviors, and attributes and combining into a one concrete class, right? That's encapsulation. Then you have a runtime polymorphism example, and you also have an abstraction, right? So because you're abstracting which method is to be called, and using this interface and abstract class, you are defining a level of abstraction wherein you are not displaying how it's going to be implemented. All you are exposing is this is what it is. You're not exposing how that is actually being implemented. Example of abstraction. Okay, then I'll move to the next one, test 4. Basic example. For example, there is a bank. Bank always has to have a rate of interest. Now, rate of interest can be different for different banks, right? Again, as I said, in the beginning, you just define that a bank should have rate of interest. How that rate of interest should be implemented by a specific bank is up to the bank. So SBI has 9.15, PNB has 9.7, and if you have a separate bank, then you can implement that bank with the same rate of interest, but different values. So idea here is again the same. A bank has to have a rate of interest. How that rate of interest would be, how much rate of interest would be, it depends on the bank, and bank has the privilege to implement it. Okay, but we are enforcing that if you are a bank, you have to have a rate of interest. Okay, now if I go to next one, test 5, same example but slightly different. So I was talking about this, that if you have a requirement where you have to implement 2 interfaces. So this is multiple inheritance. That means if you have something like this, then you have to implement print as well as show. So here I have said printable comma showable. Then you have to implement print and show both. This is not available with the abstract class. So if you have requirement like this, then you can use interface. And if you don't have such requirements, you should go to and use abstract class, because as I said, abstract class is near to a typical class, and it has a lot of other features which a typical class has. Interface doesn't have those features. So if you are confused, go and use abstract class. As simple as that. Now next one is test 6, which is drawable to, I think it's almost the same, no difference here as well. Same thing is happening, drawable, where you have example of default. Okay, so in the case of default, an interface, if you this is been introduced in Java 8. So if you have a method called as method which you wish to implement, right, then you can use it. Use default, and you can put the concrete method inside the interfaces. This has been added because people was facing difficulty, because people first thought that they won't need any concrete class to be present, concrete method to be present inside interface, and later 2-3 years later they realized that they need to have it. So the moment they actually added that method here, they had to implement it in all the classes. I'm damn sure no one has understood what I just said, and I don't want to complicate this further. So I won't explain that example. Maybe when we do interviews later, maybe then I can try to explain what I was saying. Or you can also Google it and try to understand. And if you don't get it, then we can talk. So the side is simple. There was a problem statement people were facing with interface. And the moment someone added anything, it has to be implemented in all the subsequent classes. And this was a pain. That's the reason they just added a mechanism that you can simply write a method which is default, and so no one has to implement it. So once if you mark it as default, all the child classes will have access to it. So in the rectangle 2, default method you are not implementing, and a message you are not implementing. So once you mark it as default, your job is done. It's available to everyone. You don't have to implement it. If you don't mark it as default, all the child class has to implement it again. So imagine you have a drawable interface, and based on drawable, you have 50 or maybe 200 classes in your program. It's normal thing. You shouldn't be surprised. Sometimes a single interface has 100 implementation or 500 implementation or 1000 implementation. And imagine someone later adds a method in the interface. Some behavior has been changed and some method has been added in the interface. What will happen? All the 1000 classes has to be modified, which is a huge work. And modification is not that big a deal. When you modify something, you are likely to put defects, right? So open for, there's a concept basically, open for extension, closed for, open for extension, closed for modification, right? So you can extend something. This is just a principle I'm saying, open for extension or closed for modification. This is again, I was talking about solid principle. It's something related to that, okay? So open and close is called an open and close principle. That is, you are open to extend something, but it should not be modified because of that change. And since there wasn't a default feature here previously available, you have to modify all the 1000 classes. So you're kind of modifying it, which is a wrong thing to do. Okay, that's the reason the creators of Java introduced this default, because simply they said, if you're marking something as default, that none of your classes, child classes, need to implement it because it's already implemented. Okay, so interface has had this shortcoming previously, and now it doesn't have that shortcoming. And that's why I was saying that interface and abstract class now are at par to each other, because both are capable of doing both the things, the most important things. Of course, there are other things which interface has, for example, these kind of things. There are of course some subtle differences between these two, but more or less conceptually they are almost the same now. All right. Any questions so far? No questions? Okay. All right. I don't have any other I should say a topic to discuss today. I do have an example which I would again share related to interface and abstract class. Nothing new, almost the same thing which I already discussed. But to give you another perspective, I thought I would try to explain that to you. Again, it's not a real-time example, just an analogical example which I would try to give it to you. So something like you want, or think in this way, maybe in the beginning of time, when our universe was being created, and let's assume that we had God then. So God wanted to create our, the whole system, right? So there can be, you can say, two systems. One is the non-living system and second is the living system. Okay. Now the God thought, okay, I want few things to be created. One are living, one are non-living. The idea was clear. So right now God is thinking about what? Okay. And here you can compare God with the architect of your software. That's how architect think. The way God is thinking and the way I am about to tell you, that's how architect think. He will first focus on the what part. Okay. So now the what part, he said, okay, I want a living and a non-living. Then in the living, I could have three kind of things, maybe sea animals, land animals, and air animals. Okay. Now this is clear in his head. Then he would say, okay, now in the living, in the land animal, it should have some behavior. The sea animal should have some behavior, and the air animal should have some behavior, right? So he will first list down all of this in a format, which I'm going to show you how. And once he creates that format, then he will not go and create by himself. He will ask his workers, maybe some demigods, and he will say, okay, this is the list, this is how, and something has to be created, and you just focus on this and just start creating, right? So I'll just, for the sake of what I just said, I'll try to explain this. So I will say, okay, create a package. So now, right now, God is doing it. Okay. So God will say, okay, abstract class and interface. I want to create universe. We'll say, okay, so I will create a universe and I will have a package. Here I'll say concepts. So first he is doing some conceptual, wiring. He will say, I'll first create an interface. I'll say, what should I have? I should have a living organism, right? Living, something living. And what this living should have? Living should have few behaviors, right? So it should have, it should breathe, or it should eat, and it should reproduce. This is the definition of a living organism. If a living organism can't do these three things, maybe you can say it's not living. Okay. Now, the God is clear on this. The architect is clear on this, that these are three behaviors he need to have in order to create a living organism. Okay. Then he thinks, okay, but I also need a sea animal and I also need a land animal, and both are these two things are different. Now he can choose to put an interface, or he can choose to have an abstract class, doesn't matter. In case if he has a behavior which he thinks has to be predetermined, then he can choose abstract class and he can put some behavior, maybe something like this: void predefined behavior, something like this, and he will declare something here. He'll declare something. Oh, sorry. Right, he can declare something here and he will say default. So this is available, and if you don't want to use default, he can just change this to abstract class, and then he can remove the default and you can just simply say abstract class. What is the error? Am I making a mistake? Oh, so I have to change this to abstract. Okay, so depend what mechanism you want to use for templating. Either you can use abstract class or you can use interface. I'll just move this back to inter because I just have to make a lot of changes unnecessarily. I'll just revert this. Right, this is what it is. This is what got thought in the beginning itself. Okay, then he thought, okay, I need few more animals. So I will say, okay, I will create an interface, and this interface will have land animals. And here he will say, okay, I will be extending I living. Okay. And here he would say, because this is a land animal, right? So he should be able to walk. The land animal walks, right? So he will just say this. Then he will say, okay, I want to create a sea animal. I see, and I'm putting I just to mention that this is an interface. This is just a nomenclature which people use in the industry. So I see animal, and the sea animal has a separate behavior, right? So sea animal is extending, and it will have a method of its own called as swim. So understand it this way, that this is how the God is first of all templating. He's planning. This is the planning part. Okay. Now then comes the implementation part. I will say human impl. Okay. Now these are the workers. This class is being created by the workers, right? So worker got this instruction from God that, okay, that this is how a land animal is to be created. This is how a sea animal is to be created. And now they have instruction to create a type of animal. Let's say in this case, human type. So when I say human, and I have, because the worker doesn't know what kind of behaviors human should have, because only the architect or the God is aware about this. So what they will simply do, they will say, okay, I will implement I will implement land animal. Okay, I will say I implement land animals. The moment I do that, the very same moment, if I do click on, I click on add an unimplemented and add an unimplemented method, I will get this list automatically here. So I now got the instructions given to me by God, and I would now know what is to be implemented. How I know that? Because I'm an engineer. The worker is engineer, and they can know how can they make a human breathe, right? And how can they, if they want to create a shark, they have to implement a sea animal, and sea animal they have to implement a method called as swim. So if I go and create a sea animal, implement sea animal, or let's say I'd say shark in this case, shark impl, I should be implementing I see animal. Oh, okay, sorry, I did a mistake here, not here. Shark impl, I should be saying I see animal. I will just remove all of that. I will import this and I will click on add on implemented. So here, breathe, eat and reproduce is coming from where? It's coming from living. It's coming from here. And since sea animal is extending I living, so that means whatever was here is now has become part of IC animal. So this IC animal, whoever will implement IC animal will have to implement 4 methods. One is swim and 3 here. And that is what is happening in the shark impel case. These three methods is coming from I living, and this one method is coming from IC animal. So the worker will now know exactly what is to be implemented. How it is to be implemented, that he can figure out because he is an engineer. Okay, so this is just an analogy I was trying to give on how you actually create an application, how a Java developer should be creating an application. He should be first doing a templating. Sometimes you yourself actually is an architect as well as a worker, right? So you yourself will have to first create the plan, and once you are done with the plan, then you go ahead and create the implementation. So this is your plan, concepts plan, and you use impl package to put the implementation of different plans. All right, so I have tried my level best to explain you how abstract class and interfaces work. I hope I have done justice to the concept. If still you have a concern about it, doubt about it, so I would recommend you to work on some assignment which I'm going to give. So as I always say, these examples which I've given you are not for me to demonstrate only. These are for you to try it out as well. So if you're not, after attending this 1 hour lecture, if you're still not able to understand this, what I would suggest you to do is to try this first. Create these classes yourself, try to understand this. And then after you try and you still don't get it, then you can reach out to me, and then I will try to explain what it is, whatever your doubt is, and maybe I will try to explain all of this again, maybe with some different examples to talk about. Okay, but one thing is for sure, that you won't understand it completely unless you work in a project. Okay, and that is why I was saying this, that we need to jump on to actual thing for which we are learning all this, because this is not what it is. I mean, this is not you cannot learn this in isolation. I mean, what I want to say, you cannot learn this in isolation. You need to learn how you will implement this in an actual program and in a right context, right? So our context here is automation testing framework. How we can implement these concepts in an automation testing framework is what you need to understand or practice, and then you can actually comprehend what really is happening. You will never create an animal class, right, in a live program, right? You will be creating something different, something contextual, something meaningful for that specific project, isn't it? So that's the reason you need to jump onto it as soon as possible. I published the quiz, and I got mixed responses. Few people said that we should be working on Java more and should not be jumping onto Selenium straight away. And few said that they are okay. I will give another week on this. So we will be doing Java for a few more days, but we cannot afford to spend too much time on Java because that is not our end goal. Okay, if we continue to work on Java for another 1 month or 2 months, you're not going to get any job. Okay, our purpose is to get a job, right? And that job we need to land up quickly, and that's the reason we need to start doing things in parallel, and you need to start spending more time with the assignments and with Eclipse and Java as well as Selenium. And trust me, we are not only going to learn Selenium, we also have to do API automation, right? So your profile, let me first stop the recording.